All right, so I think this is recording. Let's take a look at these three equations. They're asking us to solve these. The variable is an exponent for each problem. These equations are referred to as exponential equations, and for now we're going to solve them by using the property that exponential functions are one-to-one functions. So on the number 7, I can see on the left-hand side that the base is 7. And the 7 has an exponent of 3x minus 2. So we're going to eventually try to rewrite the right-hand side so that it has a base of 7. So first we recognize that 49 can be written as 7 squared. But still, right now, it's easy to see how we're going to get the 7, but right now that base is still 49. 7 squared is still 49. So I have to use the properties of exponents and recognize that when I have a power raised to a power, that I multiply these exponents. So now this base of 7 on the right-hand side has an exponent that's 2x plus 8. When I multiply that binomial, I have to use a distributive property. So since these exponential functions are one-to-one, if the numbers are the same and the bases are the same, the exponents must be the same. It's an incorrect description to say that the bases that these 7s cancel. That's not what's going on. I know it looks like what's going on, and students do describe it like that, but technically it's not that the 7s canceled, it's the fact that this exponential function is a one-to-one function. Oops. I get, if I've done my let's look real quick. I took away 2x from each side, and then I added 2 to each side. Yeah, so I'm getting 10 as my solution. Now, these do not have extraneous solutions. It may be smart to plug it in into a calculator and see if the left-hand side does equal the right-hand side, or just, if not using calculator, plug, using your head. But the technique doesn't require that we check it for extraneous solutions. We may just want to check it to see if we've made a silly error. All right, let's take a look here at number 8. With a base of 9 and a base of 27, I'm going to try to rewrite these so that they have a base of 3. So 9 can be rewritten as 3 squared. And 27 can be rewritten as 3 to the 3rd power. But now before I set things equal to each other, I need to use the properties of exponents and recognize that when I have a power raised to a power, that you multiply the exponent. So 2 times this binomial is 10 minus 2x. And over here, the same thing. We power to a power, we multiply the exponents, and we have 3x minus 15. So now if the numbers are the same and the bases are the same, the exponents have to be the same. So we can step by step try to solve for x. By adding 2x to each side, I get the variable on the left-hand side. By adding 15 to both sides, I get the constants on the left. And I know that 5 times 5 is 25, so I have my final solution here. All right, so let's take a look here at number 9. Now, on the right-hand side, we have 2 terms. So I need to get the term that contains the variable by itself, and that's common in solving equations, whether it's an exponential equation or some other type of equation. Almost always you try to isolate the term that contains the variable. So here let's subtract 16 from each side, and we get, I believe, 32, and we can rewrite the number 32 as 2 to the 5th power. And over here we have 2 raised to the 4x plus 1st power. Since the numbers are the same and the bases are the same, the exponents have to be the same since this is a one-to-one function. And now this is a 2-step equation. If we subtract 1 and divide by 4, we have our solution. Plus, it's just easy to see that 4 plus 1 is 5, that x has to be 1. All right, so I hope that helps, and I will talk to you later. Bye.